All right, example 1.46. We're finding the domain of a composite function. Anytime you're finding the domain of a composite function, there's two things you got to check. And it's not the domains of f and g. It's the domain of g, whatever the inner function is. And it's also then it's the domain of the composite expression. And what I mean by that is compose the two of the, well, I'll show you what I mean by that. So we're asked to find the domain of f of g of x. The first thing I'm going to do is check the domain of g of x. So I'm staring at this thing right here, g of x. There's no square root signs or any even roots, so I don't have to worry about taking the square root of a negative number. But I do have to worry about dividing by 0. And I could divide by 0 if 3x minus 2 equaled 0. And so I can solve to figure out when 3x minus 2 will equal 0. Well, that'll happen when 3x equals 2. In other words, when x equals 2/3. So from number 1 here, I know that x cannot be equal to 2/3. But now I'm not done yet. I still have to check the domain of the composite expression. So what I mean is figure out what is f of g of x. Well, to find f of g of x, I'm going to start from the inside out. I'll replace g of x with what it's equal to, 4 divided by 3x minus 2. And then figure out f of this thing. Well, I can figure out f of this thing because here's f of x. Here's my blueprint for f of x. So all I got to do is replace all the x's here with 4 divided by 3x minus 2. To get this, which I will now simplify. By this, the way I think about it is I know how to divide a fraction by a fraction. And that's not what I have here with this complex rational expression, but I can make it so it's a fraction divided by a fraction. Instead of 5 up in the numerator, I can think about that as 5 over 1. Bam, it's a fraction. But what about the denominator? That's not a fraction. It's a fraction, really a rational expression, minus some whole number, 1 here. So I got to kind of mash this all together to make it a single fraction. And the way I do that is I need to get a common denominator. So I can leave this 4 divided by 3x minus 2 alone, but I can view this 1 as 1 divided by 1, and then multiply the top and the bottom of that fraction by 3x minus 2 to get to here. And what that allows me to do is view this thing as 4 minus 3x minus 2. 4 minus 3x minus 2. Note the parentheses there. That's very important. I want to subtract this entire thing all over 3x minus 2. In other words, 5 over 1 divided by, if I distributed this negative through, I get negative 3x plus 2. And this 4 and this 2 would give me 6. So I got 6 minus 3x divided by 3x minus 2. And finally, I don't know where I'm going to go, maybe over here. I can simplify this thing. I can say it's finally a fraction divided by a fraction, and the way I divide fractions is kind of like multiplying fractions, except I multiply by the reciprocal of the denominator. In easier terms, take this thing and flip it upside down. Flip the bottom upside down. 3x minus 2, 6 minus 3x. And you're like, oh, now cancel out those 3x's? No, do not do that. Don't cancel out these 3x's because you can only cancel over multiplication, and this 3x is part of a subtraction here, 3x minus 2. So because of this minus sign or this minus sign, I cannot cancel out those 3x's. So I guess I just have to call this, I don't know, 15x minus 10 divided by 6 minus 3x. That's one way you could express this thing. Wait, what was I doing again? Didn't this have something to do with the domain? Oh, right, I'm figuring out the domain of the composite function. I figured out part 1 pretty easily, but to figure out part 2, I had to do all this work to get to here. And then I had to figure out when is this thing undefined. Well, it's undefined if 6 minus 3x equals 0. Because if 6 minus 3x equals 0, I'd be dividing by 0 right here. So if I add 3x to both sides of the equation, it's undefined when 6 equals 3x. In other words, when x equals 2. So from this one, I know that x cannot be equal to 2. So therefore, for my final answer, I would say that the domain is all real numbers except for 2/3 and 2. Or if I wanted to write that in interval notation, I say it's everything from negative infinity up to 2/3. Union, everything from 2/3 up to 2. Union, everything from 2 up to infinity.